we're going to start looking at some different problem-solving strategies. Some possible methods that you may or may not already use would be to draw a picture. This is one that can be very helpful because it gives you a visual representation of your situation. Sometimes you can use a common formula. So if you know that you are dealing with the area of a triangle as part of your problem, you might want to keep in mind your formula for finding the area of a triangle. That might come in handy. You can write a verbal model, and what this is writing down kind of your thoughts as far as how you think everything is related. So instead of just writing strictly an equation, you would write it out in words instead. You can use a simplified similar situation. If you're getting hung up on the numbers that are in there, maybe it's fractions, maybe it's some decimals, try a simplified situation using some numbers that you're comfortable working with. Get your setup, your process, and then go back and replace the numbers that you actually have for the simplified ones. You can look for a pattern. Sometimes it helps to make like a little table, and you can see if there's a pattern. Maybe you add 2 every time for whatever problem you're solving. So you can look for a pattern. One thing to keep in mind is it takes a lot of practice to actually become a good problem solver. It takes a lot of times being wrong before you get maybe the right answer. But one thing you have to remember is that it takes practice. So you have got to keep working at it. Okay, one thing that I have found to be absolutely critical for the kids is that before you even begin thinking about equations and formulas, you have got to identify the variables. So you have to ask yourself, what is it that we don't know about the problem? Now, a lot of times you will find this in the question. You know, what are they asking you to find? But a lot of times there's more than that. There might be several different things that we don't know about our problem. So it is absolutely important to identify what it is you don't know, and that includes assigning them a variable then. So let's say I'm working with a problem and I don't know the amount of time walking. So I might let t be time walking. I want to make sure that I identify what it is I don't know and assign it a variable. So that way when I'm doing my problem, I can look back and have it all right in front of me. I know that t is the time walking. Okay, here's our first practice problem. It says the Metro train runs between Auburn and Bell. If it does not have to stop, it covers the 123 miles in 1.5 hours. What is the average speed of the train when it doesn't have to stop? So the first thing you'll want to do is read through it just to get a general feel of what's going on, and then usually you want to go back and read through it again and try to figure out what's important. So as I go back here, I'm going to just look at it sentence by sentence. It says the Metro train runs between Auburn and Bell. Okay, so I'm going to do just a little bit of a visual here, and I am going to let my first dot be Auburn and my second dot be Bell. So here's where my train is going, between those two. If it doesn't have to stop, it covers the 123 miles in 1.5 hours. Well, this right here tells me that the distance from A to B is 123 miles. Even though they didn't come out and say the distance between the two towns is 123, based off of the fact that it says it covers the 123 miles, that's indicating the distance between A and B is 123. So I went ahead and I wrote that down underneath my line so I know that the distance there is 123. And it takes 1.5 hours. I'm going to jot this down off to the side here, just so I keep that in mind. So this is the time it takes to travel. And this 123 was my distance. Okay, what is the average speed of the train when it doesn't have to stop? So here's where I'm going to find what my variable is. This is what I don't know. It wants the speed, the average speed. So that is my variable. That's one of my unknowns. It might not be the only one. We'll have to check and see how things work out. There might be another one. So I am going to put down speed, and I am going to assign it the variable s. Now be careful about using the variable s if your handwriting isn't really clear, because sometimes it can be mistaken for a 5. So if you want to use speed and put down an x, that's fine. You can use any variable you want. So now I want to look at the situation and look at what I have. I have a speed, I have a distance, and I have a time. I want to think about how are these things related to each other. And for this one, I'm going to use a common formula. And that formula we're going to use is rate times time is equal distance. The reason I'm using that one is because I have a distance, I have a time, and I need a speed, which is actually the same thing as a rate. So that leaves me with only one unknown item there, which means it's solvable just in with this one equation. So I'm going to go through now, use this common formula, and I'm going to replace the variables with what I know. Well, my rate I have used as S. My time is 1.5 hours. And my distance is 123 miles. Now I can go about solving this. I need to isolate the S, so that means I need to get rid of this 1.5 hours. Well, since S is being multiplied by 1.5, in order to undo that, I need to divide everything by 1.5 hours. And to keep it equal on both sides, I have to divide over here by 1.5 hours also. Now on the left side, those will cancel out and turn all into 1, so I'm just left with S. And on the right side, I have 123 divided by 1.5. Now, you could leave your answer as 123 over 1.5, but it's not the best form for your answer, because most people aren't going to say that they traveled 123 over 1.5 miles per hour, because that's what our label is going to be. If you look at the labels we have left over here, it's miles per hour. So you're actually going to want to divide this out. Should come up with 82 when you do that division. Now make sure you hang on to your label. It is miles per hour based off of the way our ratio is set up. So it's 82 miles per hour for our average speed for the train. So here's practice 2. Miley is tilling a rectangular vegetable garden. She wants the length to be 3 times the width. She wants the fence around the garden to be 350 feet. What dimensions should she make her garden? Okay, so first read through it, and now I'm going to go back and kind of dissect it, figure out what's going on. So it says she is tilling a rectangular vegetable garden. This right here is important. It's telling me the general shape. So I know my garden is rectangular. She wants the length, so I'm going to call this side length and this side width. She wants the length to be 3 times the width. Okay, I'm not quite sure what that means right now, so I'm just going to come back to it. She wants the fence around the garden to be 350 feet. What dimensions should she make her garden? Okay, right here, I've got to identify what I don't know, and that's coming in this question. What dimensions should she make her garden? So what they're asking me for is the length and the width. So I'm going to assign them each a variable, and I'm going to use L and W just so I can keep them straight, length and width. Okay, now I'm going to go back. There was 2 things that I didn't use yet. The fact that the length is 3 times the width, and she's putting a fence around this garden. That's 350 feet. Well, now I've got to think about if I'm putting a fence around something, I want to think about what property of my shape is that. And hopefully you'll recognize that that is a perimeter. When I want to go around something, I'm looking at a perimeter. So now I want to think about perimeters of rectangles. How do I find my perimeters of rectangles? Well, I would add all the sides together. So I would have L plus W plus L plus W. I'm going to write that, instead of writing both of the L's, I'm going to put 2L plus, and then instead of writing the W twice, I'm going to put 2W. So I know my perimeter is 2L plus 2W. This is a common formula. So far I've sketched a picture, I've used a common formula. Now I've got to go back and try to fit this all into place. The 350, that is my perimeter. That's how far I want to go around. So I know I'm going to put that in the place of my perimeter. I still need my L and my W. A. And the only place it really talks about my length and my width is in the sentence where it says she wants the length to be 3 times the width. Well, if I'm not sure what that means, I'm going to do a simpler case. So she wants the length to be 3 times the width. I'm going to pretend that in my vegetable garden, I'm going to pretend the width is 2. So if I want my length to be 3 times the width, well, that means my length would have to be 6. And to do that, I took 2 times 3 to get it to be 3 times. Okay, well now I'm going to do a different one. Maybe I'll be able to find a pattern. So what if I want my width to be 3? Well, 3 times as far would be 9. So then my length would have to be 9. So in order to do that, I took 3 times 3 and got my 9. Okay, let's jump up to, what if it was 10? My width was 10. Well, 3 times that would be 30, and in order to get a 30, I would have to take 10 times 3 to give me my 30. Now I can go back here and I can find the pattern. Each time I did a simpler case here, a different scenario, the 2, the 3, the 10, that was my width I was using. So, based off of what I've said down here, that would be my W. Now as I look here, the symbol didn't change at all, so I'm still going to keep a multiply. And right here, the 3 stayed constant also, so I'm going to keep the 3. Now the 6, the 9, the 30, those were all changing, and when I go back to my scenario, that was my length that I was dealing with. So instead of a number there, I'm going to put my L. So now I have L is equal to W times 3. Well, I'm going to use that because now I know what L is equal to. So down here in my formula, I'm going to plug that in. W times 3. So I've got my length figured out. Now I need to deal with my width. Well, if you look at our formula, we already have W here, and I use W right here. So my width is just going to stay W. You might be wondering how come I couldn't just go 350 is equal to 2L plus 2W. And the reason for that is right now it has 2 variables in there. And we can't get a numeric answer with 2 variables in there. So I had to use this piece of information to figure out, well, what's L actually equal to. Now I have a problem that I can solve. So I can take my 350, take it times, or not times, take my 350 is equal, and then I can multiply 2 times the 3W. That'll give me a 6W. And over here I have 2W. Add those together, and I get an 8W, so 350 is equal to 8W. Then to get rid of that multiplying by 8, you divide both sides by 8, and you'll end up getting that W is equal to 43.75. So that tells me my width should be 43.75 feet. Okay, now that's not what the question actually was only asking for. It says, what are the dimensions? So I need my length and my width. Well, to get my length, I can go back up here to where I had L is equal to 3 times W, and I can take 3 times my 43.75 now to actually get what my length is. And when I do that, I get a length of 131.25 feet. So those would be my dimensions. 131.25 by 43.75. So on this one, I used several different things. I drew a picture. I used a common formula down here by the perimeter. I did a simpler case. I used some numbers because I wasn't sure what this phrase meant. Then I used those numbers and I looked for a pattern up here. So that one took several different problem-solving strategies.